Hello, I am sure all of you are doing fine. Now, so far we have discussed in projection of planes how to get the projection of a given plane when it is inclined to one of the principal planes or the reference planes. Now, the next condition what we are going to see is the oblique condition of a plane. That means the plane is inclined to both the reference planes. Now, it will be very easy to understand this oblique condition with the help of an example. Right? Now, let me first explain you how the second inclination can be involved in the given plane. Now, we have seen that, say, it is very important to draw the line in the projection. We need one line, right? And that is why what we did was we have placed the plane in such a fashion so that we are able to see its trace length or the trace, or we see that plane as a line image. So the line image of a plane is called as the trace. Now, when this is possible, when can be the image of a plane will be a line? When it is perpendicular to one plane. So, if, say, let us consider this plane. Now, this plane, when I make it parallel to HP and perpendicular to VP, so I am getting the front view of this plane as a trace or a line, right? If I make this plane perpendicular to HP, I can see the trace of this plane on the top view or on HP. Now, how we are ensuring this perpendicularity? When we are making this plane parallel to one of the plane. So, as we have seen, if I want to draw the surface inclination in the top view, that means there in the top view I need to see the image of the plane as a line. So, I need to make it perpendicular to HP. And how I can ensure? When I make this plane parallel to VP. So, when I make this plane parallel to VP, so then I will be able to see the front view as the true shape of the plane and the top view as the trace length, right? So, as in most of the cases, we know what is the true shape of the plane. So, that is why at the initial step, we first try to get the true shape of the plane in one of the views. So that means the corresponding view will give me the trace length. Now let us talk about the two inclinations. Now in case of any problem or any situation, when we give the first inclination to a plane, that inclination can be expressed as a pure surface inclination, right? So the first inclination or one of the inclinations can be expressed as a pure surface inclination, either inclined to HP or inclined to VP. Fine. Now, the second inclination cannot be purely expressed as a pure surface inclination. Now, in that case, what we do is we express the second inclination with the help of some line on that plane. Now that line can be one of the edges, or it can be any of the diagonals, or for that matter it can be any selected line on that plane. So first inclination definitely, or one of the inclinations will be definitely expressed as the surface inclination, and the other inclination will be expressed with the help of some line on that plane, and that line can be any edge of that plane, or for that matter a diagonal of that plane, or any line on that plane which will be known to us. Fine. So it is very easy, it will be very easy to understand this oblique condition, projection of oblique planes with the help of an example. So here I have taken a very simple plane just to develop the understanding how we are going for the projection of an oblique plane. Now in the problem it is stated that there is a rectangular plane of size 30 by 50. So I can take it as 30 units by 50 units or 30 mm by 50 mm. So a regular plane of size 30, rectangular plane of size 30 by 50 is resting on one of its shorter edges with its surface inclined at 35 degrees to HP. So there is this plane which is resting on HP, right? It is resting on HP, and what is the shape of the plane? The plane is a rectangular plane. So it is a rectangular plane, right, which is 30, shorter side is 30 and the longer side is given to us as 50. So it is 30 by 50 rectangular plane, and it is resting on HP. It is resting on HP, that means maybe on the ground. So it is resting on HP on one of its shorter edges. So a rectangle is having two short edges. These two are the longer edges. So it is resting on one of the shorter edges on HP. So if my palm, let us say, is the HP, so it is resting on HP on one of its shorter edges, right? And the edge on which it is resting, so now we are talking about the second inclination. See, this is the first inclination, which is surface inclined at 35 degrees to HP. So one inclination is pure surface inclination mentioned. Now second inclination, how the statement goes: the edge on which it is resting, the edge on which, so let us say it is resting on this, it is already stated resting on shorter edge, so I select this one as the shorter edge, and this is resting on this shorter edge, and this shorter edge is inclined at, this shorter edge is inclined at 40 degrees to VP. So see how the second inclination is put into the situation. So it is inclined at 35 degrees to HP, and the edge on which it is resting, this is inclined at 40 degrees to VP. So this is how the plate is, or the plane is placed in the quadrant, right? So that means in the front view you are able to see a projected shape, as well as when we look at it from the top, as well in the top view we are able to see a projected shape. The problem is clear. So again, let me explain you. It is said that it is resting on one of its shorter edge. So it is resting on one of its shorter edge, and the shorter edge on which it is resting is inclined at 40 degrees to VP. So this is how the plate is placed in the quadrant, and we have to take its projections. So let us try to solve this problem. So first, we will always write down the data properly. So what is the plane given to us? The plane is a rectangle, and the size is given to, it is a 30 by 50 size rectangle. So I need some space here, so I mentioned it is a 30 by 50 size. Fine. Then it is resting on HP. So first condition is given to us. So it is resting on HP on its shorter edge. So whichever we can select, there are two short edges. So we will select any one of the shorter edge on which it will be resting. Now there are two inclinations given. One is 35 degrees inclined to HP. 35 degrees inclined to HP. It is inclination with HP, that means horizontal plane, which will be visible in the front view. That means it is talking about theta. So theta is given to me as 35 degrees. And see here, the surface is inclined at 35 degrees. That means this theta is a surface inclination. The moment we identify it, we'll always write it this way so that there is no confusion. And the edge on which it is resting is inclined at now 40 degrees to VP. Inclination with VP. Inclination with vertical plane. Inclination with vertical plane will be visible in the top view. So this inclination is phi. So phi is given to me as 40 degrees. And this inclination 40 degrees is given with reference to the edge on which it is resting, and an edge is a line, right? So the second inclination is expressed with reference to a line, so it is a line inclination. So when we write this data, we will always proceed with putting the first condition as the surface condition. Whatever will be the surface condition we identify, we will be putting in that condition first. That means we are dealing with the surface inclination first and then the line inclination. And in our given problem, theta is the surface inclination. So we are going to add up theta in our drawing first, and then we will deal with the line inclination, that is phi. So I hope so far so good, you have understood. So now we start with the drawing. So the first thing is we draw the reference line. Now in case of projection of planes, in the last video also we have seen, we cannot superimpose the images, conditions in the same drawing itself as we could do in case of lines. Now here when we are talking about a plane is having more number of lines. So if we superimpose, our drawing will be get more complicated. So we will be segregating the steps. So now when it is an oblique condition projection, we will be solving this problem in 3 steps. Which one? First is the initialization of the problem. So we will initialize the problem. That is the initial step or the first step. Now in the second step, we put on the first condition, which is the surface condition. And the third step, which will be the final step, wherein we will be putting in the line inclination that is going to complete our projection. So we will be drawing it in 3 steps. The initial condition, the first condition, and the final condition. That is how we are going to solve it. So let us begin this. Now the first inclination is surface inclination, and we have seen surface inclination is expressed with the help of the trace of the plane, right? What is trace of the plane? Trace of a plane is the line image of the plane. When I can get line image of a plane? When it becomes perpendicular to one of the planes. How I can ensure that it has become perpendicular to one of the planes? When I make that plane parallel to some plane, right? And how I will ensure that the plane is parallel to one of the planes? That will be with the help of the true shape of the plane, right? As we know, we will get the true shape of the plane only when it is parallel to one of the principal planes or the reference planes. Now, if that is clear, now what is required for this problem? Now, the surface inclination relates to theta, right? It's a very logical statement, kind of, it will go. The surface inclination relates to theta. Theta is seen in the front view. Surface inclination is to be expressed with the help of the trace. That means I want to see the trace in the front view. right? So that means I want to see the trace in the front view. So if I want to see the trace in the front view, so first I'll have to make it parallel to HP, right? The moment I make the plane parallel to HP, then the front view will definitely give me the trace. So in the drawing, how I can ensure? I am ensuring that by drawing the true shape in the top view. So we will be drawing the true shape in the top view. Now the question arises, what should be the orientation? Whether I draw the rectangle this way, or if I draw it this way or this way. This is the question. Now for that, again I will have to look into the condition given to me. It is said that it is resting on its shorter edge. That means at any given time, the shorter edge is resting on HP. Right? So again I go this way. If one edge is on HP, the first step is I put all the edges on HP. Then I lift the other three edges, keeping one edge on HP. And if it is so, that means I'll be rotating that plane about the edge on which I am resting it on the HP. Right? So that means this theta inclination we have to draw about that edge. That means that edge I need to keep it perpendicular to VP so that I am able to see that edge as a point. Right? Because we can draw the inclination only with reference to a point. So we have to draw the inclination with reference to the edge, and we can draw the inclination only with reference to a point. That is why we will keep this edge in such a fashion that it looks like a point. So both the conditions will be satisfied in this case. So hence, whenever we see a condition that the object or the plane is resting on one of its edges, we will always keep that edge perpendicular to the other plane. So in this case, when it is resting on HP, we will ensure that one of the shorter edge remains perpendicular to VP. So in the top view, we will see that the shorter edge comes out to be perpendicular to XY. So again, you remember this point, that whenever there is an edge condition, whichever edge is under consideration must be drawn. Wherever you are drawing the true shape, that considered edge must be drawn perpendicular to the XY line. So that means this should be the proper way or positioning orientation of the plane where we are drawing. Right? Now, then the question is in the mind of students always, how far we should draw it from the XY line. So, see, we are keeping it at a comfortable distance from. Now here nothing is mentioned as such how far this plane is from the reference planes. So we will keep it, we will assume it to be purely contained from the. So one condition is for sure that it is resting on HP, but it is at a comfortable distance from VP. Right? So that is how. So we can start with then. So we will first draw one projector, which is, projectors will be always perpendicular to the XY. So we first draw a projector which is perpendicular to XY. The size is given to us as 30 by 50. So we will draw the shorter side on this perpendicular projector. Why? Because it is resting on shorter edge. So we mark the given dimension. So let us say 30 millimeters I mark. So I get this as, then parallel to this, I draw the longer edge. So we measure this as 50. and we draw the required true shape. So this comes out to be the true shape. So now we name it. So this is in the top view. So I name the corners as A, B, C and D. Right? So what we did, now we have been said that one of the edges is on HP, right? So we put all the edges on HP. So when the entire plane is on HP, so front view will be the trace which will be visible on the XY line. So when we draw the projectors for all the corners A, B, C and D, so that will be marked on the XY line. So I am able to see the trace of this plane on the XY line. So this point are the two corners, and this point are, so for front view we are looking it from this direction. See, so we have put this plate on the HP and we have turned the horizontal plane this way. So I am getting the top view here, right? And when you are looking at it, we are able to see the trace on the XY line. So now A, B, so this is point is A dash, B dash, D, C. We are looking in this direction. So this is D dash, C dash. So we have achieved the trace length in this condition. Right? Now trace, we have determined the trace. Now our job is to put in the first. So this is the initial step. So we are done with the initial step. So now we will include in our drawing the first condition, that will be in the second step. Now where we should draw the second step? Definitely at a comfortable distance away from the first step. Right? Now what is the first condition given to me? That it has to rest on. So this is A, B, C and D. Right? So we are, right now the condition is that it is resting on all the four corners on HP. Now we will keep this AB edge on the HP or ground, and we will lift this plate in such a fashion that the surface gets inclined at 35 degrees to HP. Right? Now when we are doing so, we are not changing its relation with HP or VP. That means the trace length, whatever it is, this length is going to remain whatever you are able to see. Fine. Only its orientation has changed by 35 degrees with reference to XY line. Right? So now when we are putting in the first condition, so we will first mark a point on the XY line. For the first condition, AB is supposed to be kept on the horizontal plane. So AB will remain on the XY line. So I name it as A1 dash, B1 dash for the first condition. Right? Then theta is given to me as 35 degrees. So I will draw one line inclined at 35 degrees, which is equal to theta. And this the trace has got inclined at 35 degrees to XY line. So now I can take this trace length in my compass, A1 dash, B1 dash as center, and I'll simply cut that line so that, so let me be just for approximation. So more or less. So this is this length. So we have lifted the edge CD. You are able to see the trace this way. So we have lifted this and made it inclined at 35 degrees. So the length is not going to change. So the same length we have marked. Which one? This front view length of the trace. This front view length or front view length of the trace, it is the same as the front view length of the trace. Right? we don't need to write this in the drawing, this is for just understanding. So this is D1 dash C1 dash. So we have got the first condition, right? So we have got the first condition. Now what we will do with this first condition? Now we will drop the projectors to get the corresponding top view from all the four corners. So from this condition, we will drop the projectors from A1 B1 and D1 C1, right? So what we did, we have given its first inclination, simply drop the projectors. Now here we have not changed the relation with VP. That means all the four corners, they are remaining at the same distance from VP, whatever it was. So now I can simply drag the loci of all these corners parallel to XY. So locus of A, locus of B, locus of C, locus of D. And due to this condition, the locus of A and C will be same, locus of A and D, sorry, B and C is same, and A and D is same. So we have got this network of projectors and loci. So projector of A, now we will mark the corners. So this is projector of A, locus of A. So this point must be A1. Projector of B, locus of B. This is B1. Projector of C, locus of C. This is C1. Projector of D, locus of D. This is D1. So when we join A, B, C and D, we get the first projected shape. So this is the true shape. This is the projected shape. First projected shape we have got. Now we have to get the final front view and top view for this, right? So now we have to get the final front view and final top view for this. So for the final front view and top view, so this is the first condition we have put in. Now the second condition is that we have to incline it. We have inclined it with theta, the surface inclination. Now it is said that the edge on which it is resting on HP is inclined at 40 degrees to VP. Now here you have to be very careful. Now when we are putting in the second condition, we are not changing the first condition, right? So that means whatever is the projected shape currently, the latest top view is, that shape is going to remain the same. See, you can apply this common sense as well. Now when I am looking at it from the top, I am able to see this shape. Fine, inclination is theta. Now if I change my simply orientation and look at it, I am not changing its relation with HP. I am changing only from where I am looking at it. Does the shape and size change? No, right? But only the orientation must have changed. So either if I change my position or I change the plane's position without changing the first condition. That means the shape and size of the latest view, projected shape, what we have achieved is not going to change when we are putting in the second condition. Only its orientation has to change, and that orientation has to change by how much? Such that, as if, have a look at it, as if I am turning this rectangle A1, B1, C1, D1 such that this A1, B1 gets inclined at 40 degrees to the XY line, right? So for that what we will do is, first we have to just redraw this same latest projected shape with its orientation. So as if this is the projected shape and I have to just change its orientation and draw it here such that such that this A1 B1 is inclined at 40 degrees to XY line. Now your question can be, is it necessary to tilt it this way? Can I not tilt it this way? Very well, you can do it, but we will be always placing ourselves at a safer side. We will not try to turn it this way, it might interfere the front view. So we will always try to move away from the XY line whenever we are drawing the final condition. So for that, what I will do, first I'll draw one line inclined at 40 degrees, now this is phi. So I'll draw one line inclined at phi is equal to 40 degrees. So this line becomes my reference line. Again, your question might be, where exactly I should draw this? Now it should be drawn at a comfortable distance from the latest drawing. So I'll be drawing it here because right now I don't have space. So I'll draw it here, which is inclined at 40 degrees. Yes, second inclination is given to me as 40 degrees phi. So I draw this line at a comfortable distance, and now I have to just reproduce this drawing. So I'll take this distance in my compass, right? I mark it on this line. So I get this length as, I'll just erase this so that I take this distance in compass and I mark it here. So here I get the first condition, the second condition. So we have tilted it this way, right? We have tilted it this way. So that means this is second condition we are putting in. So this is A2 and this is B2. So we have drawn A2, B2. Now we know that here the projector and locus, they are perpendicular to each other. So I can simply from A2 and B2 draw lines perpendicular to A2, B2. Right? Then I take this projected length B1, C1 in the compass, B2 as center, I cut it. So I get here, I have achieved C2 and then parallel to this. So what we have done is simply reproduce this same rectangle only by this side to be at given inclination of phi, right? So we have drawn the final top view now. Now we will go for the final front view. So for final front view, what we'll do? So what we did? So this was the first condition, this was the initial condition. Then we put the first condition, right? Then we put the first condition and now we give it the second condition. So for second condition, we have drawn the top view and now we will project it for the final front view. So now we will draw projectors from all these corners, A2, B2, C2 and so D2. So it will depend. So I am getting projector of D2. So it will depend where exactly you are getting the projector of D2. When you will draw it with exact dimensions, the projectors, if they overlap, there is no issue, but probably they will not overlap. So likewise, now I have got all the 4 projectors for the front view, final front view. So we have given the first condition, we have given the second condition. Now for final front view, what we need? We have drawn the projectors, right? Now, we have not changed theta. So if theta is not changed, that means height of all the corners are remaining the same, which is available in the latest front view, right? So that means I can simply drag the heights of all these corners from the latest front view condition of the first condition. So parallel to xy, I draw the locus of D and C, and B and A, they are on the xy line, right? So now we will mark the final A2 dash final corners for the final front view. So locus height of A, projector of A. So here I get, this is A2 dash, height of B, projector of B. I get this as B2 dash, right? Projector of D, height of D. So this is D2 dash. Then projector of C, height of C. I get this as C2 dash. So now when I join A2, B2, B2 dash, C2 dash, C2 dash, D2 dash, and D2 dash, A2 dash. So this will be the final projector, final front view of the given plate. So have a look at it. You will see that the condition what you are able to see, that is what we are able to get in the image. Now one thing you need to be careful when you are drawing, you must draw all the projectors and loci faint. They are construction lines, so they need to be drawn lighter, right? And wherever you are marking the trace and the shapes, the true shape trace, projected shape trace, projected shape and projected shape, when you are drawing these needs to be prominent or darker. It should look prominent in the network of the locus, the loci and the projectors. So I hope the two conditions are quite clear with the help of this example. So in the coming videos and lectures, we will deal with more number of problems. So that's all for this session.